All right, so earlier we were talking about inverses and how we can find inverse functions. And one of the things that we really want to do is do the following. So can we find the inverse of an exponential function? Okay, so that's what I want to do. I want to find the inverse of an exponential function. So let's say you had f of x equals a to the power of x. So we want to find the inverse of this thing. So remember, in order for me to find this inverse, I'm going to change this f of x with a y. And then what I'm going to do is I'm going to flip the x's and the y. So x equals a to the power of y. Can we solve this? Well, we can't divide by a, we can't divide by y, we can't do any of that stuff because the y is on the exponent. We don't know how to get rid of it, okay? So at this point, we go at a brick wall and we want to make sure that we do something different. So we're going to introduce a new notation, okay? So here is a definition. And we're going to say that the inverse of this particular function is going to be defined as the following: log base a of x. So the way you say it is log base a of x. That's how you're going to say it. And basically what this log thing means is the power which we raise a to get x. So what power should I raise a to get an x? Okay, that's basically what this log means. And log is Greek for logos. There actually is some meaning behind it of why we chose log. So you can research that if you'd like, but there's a reason why we chose log. But that's basically what it is. So a little things about this log function and what exactly it does, and we'll do some examples. So the function f of x is equal to log base a of x is the logarithmic function. Okay, so this is a logarithmic function with base a, where a is a positive number, x is a positive number, and a is not equal to 1. Okay, so here we want to make sure that a is a positive number, x is a positive number, so basically the log only gets positive vibes, if you can think about it. Positive vibes. Okay, no negative vibes. Okay, and then a cannot be 1. Okay, so basically if you were to think about the log, if you wanted to convert it back and forth, so y is equal to log base a of x, this can continuously be converted as x equals a to the y. So solving this thing would be this part. So these two are equivalent answers. This is what we're going to call exponential form. Okay, so this is exponential form, and this is going to be logarithmic form, so log form. Okay, so now what we're going to do, let's try to practice converting between those two. So this is what we're going to do. So here's my example. Oops. So convert to log form. So let's say we had 2 squared equals 4. So this is exponential form. We know that this is true. We know that 2 squared equals 4. We want to just convert this to a log form. So the first thing that you're going to do is you're going to write log. Okay, that's the first thing you want to do. Then this 2 that's right here is going to get really, really small. So it's going to be really, really small. See how it was really big? Now it got really, really small. Then this 2 and this 4 is going to switch place. So now you're going to have a 4 here is equal to 2. That's how you're going to look at it. Okay, because if you look here, the log form, let me write it like this. Log ax equals y. If you compare this thing to this thing, right? So this particular thing, this a got really, really small. Let me write it here. This a got really, really small. Then the x and the y switch places. Okay? All right, let's do another one just to make sure. Okay, so we still want to convert it. This is going to be 3 to the power of x equals 27. Okay, so how do I convert that to log form? Well, this is going to be, we're first going to write log. The 3 is going to get really, really small. And then the x and the 27 are going to switch places. 27 is equal to x. So log base 3 of 27 equals x. Okay. All right, so let's try a couple more. Let's say we had c to the power of x is equal to 100. And then we'll do a to the power of y is equal to z. Okay, so first things first, we're going to write log. Let's first start by writing log. What is going to be the base? The base is going to be c, so c is going to get really, really small. And now we're going to switch these two. This is going to be 100 is equal to x. Okay, now for the other one, the first thing we're going to do is write log base a. Now the y and the z are going to switch places. So this is going to be z is equal to y. Okay, and that is my answer. Okay. All right. So now what we want to do, let's do the opposite. Okay, so now that you felt comfortable with that, we are going to convert now to exponential form. So let's convert from log now to exponential. All right. So first we're going to write 2 is equal to log base 4 of x. Now, usually when I convert these, I like having the log first and then the numbers. So if it helps you, I like always having log base 4 of x is equal to 2. So just swap them. Okay. So the way that I usually remember this is that I always start with the 4. And then what I do, I kind of loop around. I do this little thing. So what I say is 4 to the power of 2 is equal to x. Okay, so 4 to the power of 2 equals x. So this is going to be 4 to the power of 2 equals x. Okay, and that is my answer. You don't need to solve it. Let's just do it like that. Okay. Let's do another problem. Let's say we had log base 3 of x is equal to y. Okay, I have it in the form that I like. So we're going to say 3 to the power of y equals x. So this is going to be 3 to the power of y is equal to x. Okay, so these aren't too bad, I hope. All right, so let's do another one. So part C, log base 10 of 1 equals 0. All right, so here is the 10. I'm going to loop it around. 10 to the power of 0 equals 1. So this is going to be 10 to the power of 0 equals 1. And we know that that's true. Anything to the 0 power is always going to give me 1. Okay, so these are not too horrible, I hope. It just looks fancy notation. Some of you guys have seen it, maybe some of you guys have not. But what we're going to do in the next one, we're going to do a little bit of graphing. So, and it's not going to be too, I'm not going to go too advanced in the graphing. And then we're going to do a couple common logs before we get to the equations.